Good morning. Thanks for joining this webinar. This is Jim Morris speaking from NSF Health Sciences. If you're just joining the call, please do remember to mute your phones. And as I mentioned just a second ago, following this webinar at some point later today or by tomorrow, we will send out a PDF rendition of these slides for those that have called in to participate in the webinar. I have a number of slides to present, and I suspect we'll take a good portion of the hour that's been put aside for this, and hopefully there'll be some time towards the end to take a few questions. Again, thank you for joining, and we really appreciate the interest in this topic. The focus of this webinar is around human reliability. It's built on our materials related to human error avoidance, and the specific topic that I'm going to cover in the next hour or so is around categorization. I may have met some of you face-to-face. And good morning. Thank you for joining. My name is Jim Morris, and I'm with NSF Health Sciences. I've worked with NSF now for about 6 or 7 years. And prior to that, I was with a small biologics manufacturer in Boston as head of quality and regulatory. And prior to that, I had various roles with Pfizer and with Johnson & Johnson, always in manufacturing and quality management. And so much of the 30-plus years, or a little bit less than 30, thankfully, have been in close to operations, and a common theme in many of the operational roles that I've had has had to do with investigations and managing issues related to operations in the pharmaceutical sector. So I'm happy to present this webinar. I've been involved in teaching this material for a few years now, and I'd like to present the group of experts that we have within NSF Health Sciences that are very close to this material. As some of you probably know, we have a large cadre of people that we have in place to provide our consultancy and training services. Within the area of human error, the folks that are shown here are those that have particular expertise, and some of you may have met the individuals that are shown here. Martin Lush, photographed in the upper right, is really the sponsor of this material and is president of NSF Health Sciences. Martin championed the topic of human error within NSF. Prior it was David Begg Associates, as some of you may recall, and developed the materials and is still very passionate about the topic. And so much of what we've put forward is based on his initial work and, frankly, his ongoing work. I'd like to also mention that lower right, Andy Barnett, previously with the Becker Group, is someone that can tackle a problem very, very methodically. And if you have a very sticky situation, something that won't go away, Andy's the guy to put on it. He has the statistical background, the methodical approach that it takes to really get to the root cause of a difficult investigation. Some of the people here are based outside the U.S., so we really have global capability. But that's our team of experts in the area of human error, and we can go beyond that as need be. Before we get into the topic of categorization, I'd like to describe the program that we have very, very briefly and then provide some context. And the way that this set of slides are organized, it's really around providing you with some context, some background, getting into the categories that are based on the materials that we put forward, and then giving you a sense of the importance of company maturity in doing this properly. We've been, based on the work that Martin Lush began doing, I'd say probably 5 years ago, our topic, our training, and our work in the area of human error avoidance has evolved. And it's matured over a period of time, and I think in a really healthy way. What we realize is that when we look at this topic of human error, it doesn't go away. It's not easy to get it right, and yet it's very important that we get it right. And companies are certainly paying attention. What we feel is that you need to consider two approaches, really. One is to deal with the investigations that you're having to do on an ongoing basis and assuring that those are done really well. And that we would call the reactive side of dealing with the issue of human reliability. But obviously, if we're successful, we're looking at this in a very proactive way. And we have tools and techniques to deal with things proactively, to do effective assessments, and to get to a place where we're avoiding situations where errors are occurring. So we spend a lot of time on the left, we spend a lot less time on the right, and we should shift to the right. When we teach this material, we spend time on both. We focus on investigations and doing them well. What we want to do is spend more time on the proactive side. But that gives you a sense of the program, and I'll speak a little bit further towards the end of specifically how we, the courses that we offer that deal with this. What I do want to emphasize that whatever NSF Health Sciences does in this area, it's built on a pretty thorough understanding, or at least we feel a fairly thorough understanding of the science of human error. We spent quite a bit of time assuring that it's based on our experience base, but also based on what's out there in the literature and what best practices are being followed to deal with this topic of human error or human reliability. So the academic references for this particular webinar, and strongly for our human error materials, is from James Reason. And the work that we've done is largely built and aligned with James Reason's principles around human error. The reference on the right was handy for the preparation of the materials that I'm putting forward here. But the primary reference that you would want to use is the one on the left with James Reason. And interestingly, that little burn spot in the center is human error in action. That was a group of guys, me included, that tried to block the light of a projector in a conference room, as opposed to using the device itself to block the lamp, and we actually burned a hole in our book. So you realize that these things are pretty pervasive. Anyway, that's just as an aside. So let's get into the context. The situation in our companies is one where I think we all probably sometimes feel like we're being moved along a fast-moving stream and having to do our best to paddle around the rocks. And we know that we are all prone to error. That's just the way we're made up. And we're having to set ourselves up as much as possible for success and avoid the rocks in the stream. But what's such a challenge for us in our industry is that the rocks are pervasive. They pop up here and there. But importantly, the pace is sometimes very quick. There's a constant push to meet supply requirements, and at the same time, there's a constant push to raise expectations from a regulatory and compliance point of view. So we're being pulled in lots of directions, in a few directions at the same time, and expecting a lot of our people. The bar goes higher and higher every year, it seems, and that's the way it is. And we have to come up with efficient ways of dealing with things so that we don't bog down our systems. So that's the pace in our companies. It's generally that way in most firms. We've done quite a bit of work directly with companies in this area of human error and managing and improving investigation systems. In one case study, we have a facility that You could say, roughly speaking, they have to manage about 10,000 deviations in a year. And let me correct something. Not one facility. This is a company with, I believe it's 5 biopharmaceutical facilities, plants. So they're hitting at each facility, and had been in the past, say 2,000 deviations at a single site. Bioprocessing, so you would expect it to be complicated. So in this case, we're seeing about 70% of the deviations had some association to human error, which is consistent with what we found and what we've seen with other companies, but also just through our research with other industry sectors, that it is usually a very high percentage of issues have some association with human error. And it depends on how you define it. It depends on where you slice it, but there's typically a human component involved, which means that the rate is in that 70 to 96% range. So you can see pretty dramatically what the impact is if you're able to move away from such a high level. And with some companies, what we see is a reoccurrence rate that's in excess of 10%, probably closer to 20%, which means that if you're seeing these deviations over and over, you have an incredible opportunity and really low-hanging fruit to reduce reoccurrence, which has a direct impact on the bottom line. And that's where the opportunity is for companies such as this one, where the numbers are so dramatic. So as we look at the situation in the company, and we look proactively to see where they are in their maturity and their appreciation for this particular topic, and how they are working to reduce that total number of deviations, and particularly those related to error, think of that fast-moving stream, and you want to ask yourself, are you in a position where the rocks are like right in front of you and you're ready to paddle into them and you're constantly struggling, or are you in much calmer water and you've got a really good steady hand on the situation? And this kind of a webinar around categories is really fine-tuning your processes. Or worse, are you at a tipping point? Are you going to run into that situation where you've got a really potentially serious situation lurking out there and you're not aware of it? And the noise related to human error and deviations is around you. However, your systems are not strong enough, are not robust enough, not mature enough, and you may have a recall that's just waiting to occur with some relation to human error upstream. And that's the tipping point that we want to avoid. So let's get to reality. These are just a few examples of, very short examples of deviations where the operator was cited. Missing filter integrity test result. Hand valve left in the open position. Unsterilized filter used to filter a formulation buffer. In each of these cases, operator error had been cited, and these are typical situations, and interestingly, the operator was called out. So what would be a working definition of error? From reason, it's a planned sequence of mental or physical activities that fails to achieve its intended outcome. So the academic classification from reason is that there are different error types. We have mistakes that occur, and these are typically those that occur because there was something flawed in the expertise and in the planning that went into setting up a situation. So that's one type. The other type of primary error that is spoken about in his material are the lapses and slips. And these have to do with the plan and its execution. And what he means by storage is the you come up with a plan, and it might not be that you execute the plan immediately, but you execute the plan after a period of time. So you had to kind of put that information away and come back to it. So it's that retrieval that leads to lapses, that leads to error. And then we have slips that are essentially related to the execution of that plan. So that's one classification approach that's used academically. Well, it really doesn't do us very much good, to be frank. However, it's interesting because it does inform some of our thinking of how do we go about categorizing things in a way that's meaningful to us. So what we've tried to do is take this academic basis for the material that's based in psychology and cognitive science and convert that into something that's practical for our operations. So then one question to ask, basic question, is why have categories? Well, the answer is pretty obvious, and it's probably very clear to all of you that are listening here, that it's so important to be in a position to break down a problem into its subsets. And this describes a typical breakout that you would see where the applicable factors are shown in the blue. And with those factors, we're able to go down a path to identify potential solutions much more readily. So it's like the microbiologist or the engineer. We're all really good at classifying stuff into subsets so we can tackle the subsets in a really appropriate way. And that's one reason why we classify. Another is that, and this is key, that we avoid blaming people. We want to focus our attention on the contributing factors. And what we want to avoid is going straight to personnel error and blaming the individuals. Very key. So categories help us do that. It gives us a much more scientific and methodical way of dealing with an issue and not going straight towards the issue, the operator. A key principle in this topic is that there's typically it's a complicated situation. When a deviation occurs, it's complicated. There's an error chain. It's not that there's one root cause. Typically,
all right.
Please mute your phones. When we look at a problem, what we find is that there are many layers to it, and we have an error chain. And we have an error chain that we typically see. The risk of error is a function of both the individual, the physiology, and the environment, and frankly, the task that needs to be taken on. In order to reduce the risk, we need to understand that error chain, and we need to tease out all the contributing factors. So in our materials, the way we've broken out the content for the purposes of explaining this principle is we look at two sides here. The human side, which is based on the physiology of how we're made up, and then the organizational side, the environment that we operate in. When we put all that together, we determine whether or not there's a higher or lower risk associated with error. The human side, the physiological side, is broken out into these factors. So when we put our materials forward, we talk about them in the context of these 5 human factors. And that just helps us explain it to people in a way that's perhaps more organized. When we talk about the organizational factors, we break it out into these various factors. And what we're doing is basically slicing it in a way so it can be understood. But it's important to appreciate that you have a mix of individuals, personnel working in the context of an organization, And it's a combination of the two that leads to error. And we need to really understand that to be able to tease out the contributing factors. And in so doing, we can get to kappas. So a key message for us at this juncture is that when you take those 5 contributing factors that are on the human side, and you take those others related to the organization, and you run them through a filter, what you're looking to try to do is to get to contributing factors related to human reliability. If you ask 10 people, how would you go about classifying error, you're going to get 10 different classifications. Well, a key message that I'd like to put forward here is that it really doesn't matter. What matters is that you're identifying the contributing factors as you see them while conducting an investigation. Importantly, you're going beyond the surface. You're digging down, you're peeling away the layers of the onion in order to identify the contributing factors. So what would make a good category as you're categorizing? Well, just a few points here. If you trend that category, it's going to be meaningful. And if that category that you've identified is reoccurring, it helps you take action. It helps you identify a kappa. Just a few regulatory references just built in here. One is that corrective action is taken to prevent reoccurrence, whereas preventive is taken to prevent the occurrence in the first place. I want to provide that context. And the other bit of context that's important to keep in mind is that, and I could have mentioned this earlier on in this presentation, that there's a lot of focus from a regulatory point of view in this area, as some of you I'm sure can appreciate. And it's so much so that as an example, in Uterlex, as many of you probably are aware, in Chapter 1, under Quality Management Systems, human error is called out as something that needs to be thoroughly investigated. So there is attention to this, and this topic of human error and how you go about categorizing is something that makes a lot of sense for us to bear in mind and do our best to get right. So in looking at categories, not only is it that it's meaningful and it helps you identify actions you can take, but what makes a really good category is one that's built on a really good investigation program, or it's the outcome of a good investigation program. Unless you're able to thoroughly get to the contributing factors, you're going to stay on the surface. So an investigation program that's working well for you is getting down below the surface and identifying the contributing factors. When we teach this topic of deviation investigations, often in a classroom setting, we'll ask a group to put up their investigation system. And the one that's shown here is really pretty sweet. It is very simple, as it should be, and takes you from incident to kappa with effectiveness checks at the bottom. Very simple flow. That would be an example of a fairly robust investigation system. You're asking 5 whys up front. You're doing a risk assessment to triage. You're doing an investigation. You're getting to root causes, plural, and then identifying kappas. Our focus is to get to kappas that are really meaningful to prevent reoccurrence. But we can only do that if we have a robust investigation program. The one that we put forward and is linked to this particular topic on human error and is linked to our materials on human error is basically similar to what was just described on that flip chart, that we start with an incident, we identify all the problems, and then we begin to categorize. And what we do in our material is we challenge people to look at both the human factors and the environmental factors. In this slide, they're called the latent factors. The reason they're called latent is that often we don't see them until later. They occur at a later point in time, whereas the human factors, typically we see them straight away. In so doing, as described earlier, once we've broken out these factors, we're in a position to identify solutions. On the right-hand side, you can see that the elements going into each one of this flow are some worksheets that we put forward to facilitate this contributing factor analysis and identifying solutions. Basically, it's a simple flow, but categorization is pretty integral. So what I'd like to do now is put up some categories. And the categories are rooted in the 5 contributing factors related to the human factors that were described earlier. So starting with decision error, if you tease that out further, you get to what you could call a primary category. And this would be very similar to what we would see at many companies and embedded in TrackWise. What's important and what's linked to the content that we've gotten close to in teaching this material is that second category, which is related to the primary category, but it takes you a step down. It gets you further along to what might have occurred. So when a decision is triggered, when it's clear that a decision taken was not the correct decision to have been taken, you drill out, you tease out the situation depending on what occurred. And as you do so, what you find is that the deeper you go, the clearer it becomes as to why that decision was taken. And if it has to do with document structure, for instance, something was clear, the wrong information may have been present in a document, and as a result, the wrong decision was taken. So if we were to stop at category 1, we don't really get a lot of information. If we go to category 2, because we've been able to build that out through our investigative process, we get quite a bit more data. I do want to mention that this topic of culture is really important in our evaluation of human error, and we put a lot of emphasis in this in our as we deal with this topic. However, it's a bit of a touchy one, and I wouldn't frankly advise putting out that kind of a category straight away. I would look at the possibility of taking things that would consider to be cultural and move them into the organizational side of things. But we could spend a bit of time talking about culture because it's the culture in a company that helps us properly investigate things and helps us deal with opportunities for error reduction because of openness and people's willingness to share and willingness to deal with things in a proactive manner. When you don't have that situation as depicted earlier in the picture of the operator on the packaging line, when you have a blame environment and the culture is really negative, you know what people do. They retrench and you lose the opportunity for improvement. So I would call it a bit of a rabbit hole, but a very important one to deal with. However, perhaps not a category that you would want to call out. So what I'd like to do is just take this a little further, and what I'll do with each of these factors, since we don't have time to go into huge detail, I will put up each of the factors and show you how they've been broken out in a manner that relates to the content that we put forward in our materials. What do we mean by organized? Take a look at this shipping area in a facility. You can get a sense straight away just by looking at the shine on the floor that we have a very well organized shipping area. What's the outcome of that? Well, it allows people to stay very focused on the task and very, very focused on getting the work done without a lot of distraction. And that's a huge advantage for us. So when we think about decision error and we tease out the categories and we go to the level of the work environment, the organization, and then we go to what do we mean by organized, all that has an implication on how people make decisions. And it sounds a bit high level and maybe simple, but nevertheless fairly important. That's just one example of a particular category. Take learning factor. Learning factor is one of the key elements as to why people will make a mistake or not because of how it is that they were trained or how they executed a particular job. In this case, this shows an opportunity to go beyond just the training system, which might be a category that we're ticking off in TrackWise, and think about, okay, well, what happened? What was the method of training? What was the method of assessment? Was there even any training in the first place? Was the individual involved fit for duty, fit for that particular job? And then what we do with this particular topic area, this particular section on training, and looking at the method of training or method of assessment, we can tease it out further. And it's important for us to understand that the method of training has a huge impact on the outcome, as I'm sure everybody can appreciate. But it's the method and the execution of that training that's so impactful in terms of avoiding an issue that related to learning in the first place. So a question for us is, at this point, is if you look at categories in this context, what we often see a company do is drill down to category level 1, which is they call out a deviation, and it's, say, the training system. And it stops there. What category level 2 does is it allows us to go a bit further and really tease out what was it about the training system that was flawed. Was it method? Was it assessment? Was it the fact that training hadn't been done? It gives us the opportunity to drill down further. A challenge for us is, what about that tertiary category? When we're looking at, well, what was wrong with the method of training? What was wrong with the method of assessment? And I wouldn't put forward that you'd want to categorize that level, because now what we've done is we've gone to kappas. We're thinking about, well, what are we going to do to deal with this to avoid the problem with the method of training if that were to be the root cause identified in an investigation. For instance, under learning styles, you may all be familiar with the fact that we all have different learning styles. And it's really important for us, and as we design materials for training and deliver materials as supervisors, as managers in operations, that we think about our audience and how people learn differently. So as we think about our kappas, we want to do so in the context of what is it that's going to give us the biggest bang for our buck. Omission factor. This is really important and stands out strongly when we're dealing with documentation types of issues. Often we'll look at omission factor and we'll find that it's very focused on the primary categories that are listed here. However, if we tease it out further, we have an opportunity to dig down deeper and identify opportunities to minimize the possibility of omissions taking place. Now, I want to highlight the importance of change. Omission is when something is omitted in a document or is omitted in an operation. There could be many reasons for that to be the case. And often change comes out as one of the root causes most frequently, because we change things regularly and we don't do a very good job of communicating those changes. So that's something to highlight on this slide. But if we are in a position to categorize our management of changes, not just the training system, but how we manage changes when changes occurred, and if that is reoccurring and is a reoccurring category, we're giving ourselves an opportunity to improve that particular system. So unless we drill down to that second level and we leave it at the primary level, we don't really give ourselves the opportunity to identify trends that are meaningful. And that's a key message in this webinar. I'd like to drill down further on this topic of multitasking, just to put forward a little bit more context in this particular area. We work in an environment, as was mentioned earlier, that's fast-paced and complex, technically very complex. And we, as people, have limited capacity, and we have limited working memory. And what happens is we get overloaded very quickly. And as supervisors, if we appreciate the limited capacity of individuals, some having more than others, but nevertheless understanding that there's a threshold that we often reach. And we understand that by creating an environment that minimizes these things that are shown on this slide, minimizes interruptions, we just set our people up for success. And any combination of these factors causes cognitive load and impacts people's ability to focus, and therefore indirectly results in what we would call omission error. And, but its root has to do with those things that were described on the slide earlier. Interruptions being a key issue for us in today's environment with technology. We're constantly being interrupted. And when we talk about this material, we put forward ideas and opportunities that people can think about to deal with the risk of interruption, because it's such a strong reason why omission takes place, and we have issues with documentation, which is a predominant reoccurring deviation in so many companies. I'd like to move to performance factor. Performance factor, previously we'd identified it as discrepancy or application, but combined we're calling it performance factor. Primary categories under performance factor are those that are listed. If we tease out performance factor further, we can drill down further to a set of categories that help us identify improvements for each of these areas. If we have an issue related to a deviation because instructions were not clear, which is so common in our operations, we have SOPs that are super long and very text heavy, and we end up with situations because people are not in a position to follow those SOPs very, very easily, and we end up with performance issues often related to documentation. To put forward an example of what a good document could look like, we have a document that is very picture heavy in this case, which is a good thing. Basic data is called out. There's a tabular format. Initials are entered as the task is progressing. You know where the person is in the process through the sequential layout of this. The use of bold, colored words, separation for carrying out, entering values to avoid transcription error, photos with callouts. All these are simple little tools that if we use them, we're in a much stronger position to avoid issues related to documentation. I'd like to go on to memory factor is another one that can be categorized in this way. Often in the execution of a task, we make a mistake. There's an error that occurs because something was not remembered in carrying out that task. And if it has to do with training, it may be the time lag. We didn't thoroughly embed the new knowledge and the new information, and there was a time lag, and our execution was off. So we actually never took on board the new information. There was a change in a document, or a change in a way of carrying out a test procedure, and our method of assessing whether or not the analyst was competent in carrying out that change or that new method wasn't appropriate. So teasing this one out a little bit further, competency and the demonstration of competency is so important. Assuring that the method of training takes advantage of certain aspects of what makes good training in terms of anchoring knowledge, linking knowledge to prior information, and very importantly, repetition. And as shown previously, our use of attention cues and the minimizing the need to have to search for information helps us minimize the chance that we make a mistake related to document structure. So if we take this further, at least to the level of the second category, we're giving ourselves an opportunity to improve those things that ultimately were at the root cause of an error, in this case, an error associated with somebody forgetting to do something. And the column to the far right with the third level categories are essentially those ideas, those opportunities that we have to deal and put in place actions that will improve a particular situation that was triggered in a deviation. If you take a look at repetition as an example, pattern memory is fundamental to getting folks to work at a skill-based level. And the more we're able to channel that path, the greater the chance that people will be successful in carrying out a task. So much of our training needs to consider the importance of repetition, repeating, assuring that people are practiced in carrying out a task so that they're operating at a skill-based level. So that set of slides covers the 5 factors and gives you an appreciation, hopefully, of going beyond the primary category that we often see built into TrackWise and getting to a second level of categorization that is much more actionable. And the third level of categorization that I've shown really got into what you would call actions that you would actually take, kappas. But then if you were to take a step back from that and go, well, that's great. You covered things that all look very much the same. There was a common theme to the primary categories. If you think back to those prior slides, there was a lot of focus on procedures and training, for instance. What about all the other things? Well, the other things are very important because if you think about what many of you are probably using today in your categorization systems, is that you'll be looking at things such as process design, equipment, raw materials, temperature excursions. These things are all still important categories. So please look at this list of categories as just as one view of a list. These other categories are equally important. And you may go, with each one of these, you may go further and you may look at, under process design, you may have an issue related to process design at a high level, but actually as you drill down, the category that is impacted in a particular investigation is around validation or calibration or in the case of raw materials, the actual supplier. Or you might drill down even further and get down to in-process controls. So your primary category in blue, this slide should have been shifted, would be those that are listed on the far left, and your secondary category, those in green, and your tertiary would be those in red. These are equally important as the others. The distinction between the other on this slide and the ones that were presented previously is that the others are very closely linked to the topic of human reliability. And if you focus on those categories that were teased out, and also those that were considered to be the third level categories, you'll be in a stronger position to consistently drill down on things that are reoccurring when you're doing investigations. If you leave your categorization at the primary level, which is what I see a lot in companies, I think you risk not having an opportunity to deal with the reoccurring issues. So as an example, if we take in the earlier slide there was this particular deviation, missing filter integrity test result. The root cause was determined to be operator error. Well, I did a little bit of improv here and built out this particular investigation. Let's say there was a missing signature or result in the batch record for performing the final filter integrity test. And the investigation showed that the batch record had been changed and operators informed of the change during a team meeting a week ago. And the first shift operator informed the second shift operator at shift change that integrity testing was still needed. And finally, the second shift operator had to cover for another person at the beginning of the shift. Well, this is a very typical situation. If you look at the contributing factors for that missing filter integrity test, and you look at the context of what occurred and you do a thorough investigation, never is it simple. And generally you will find that there are a number of reasons why something occurred. And we're very quickly, often, unfortunately, saying, well, it was operator error. What we encourage you to do is to look at the contributing factors as you do your investigation. And now as you think about the issue of this topic of categorization, and you're trying to set yourself up to identify reoccurrence, your categories become very important. And in this particular case, if the batch record had been changed and the operators were informed of this during a meeting, maybe our change management process is not robust enough. Or, in this particular case, the first shift operator informed the second shift operator, hey guy, remember to do the filter integrity testing. Well, the batch record had changed and he was not zeroed in on that yet. So communication was an issue. If you look at this particular situation, there's an opportunity to improve changes and improve communication. And if these are categories that are called out, you set yourself up for dealing with that kind of a situation proactively. One more example. In this case, the hydraulic line was left in an open position. The procedure provided written instructions, and the line diagram of valve's position was an attachment to the SOP, line diagram. The question is document structure. The operator was transferred from upstream to downstream 2 weeks ago. He said he'd been trained on this SOP. No evidence of training was located. Work environment, training system. Operators were trained by senior operators. Okay, is that a good thing? Work environment, training system. The work unit was behind schedule and supervisors were asking for production status updates twice per shift. Planning, scheduling, work environment. So as you look at this situation where the operators failed to close a valve, as is so often the case, lots of factors went into why that situation occurred. And we could all probably zero in on the SOP as being a weak SOP if it was a line diagram, and we would say, why go with a line diagram? Go with photos, show the valve positioning. However, this was a new operator, new work environment. Maybe our training system was not robust enough for the transfer of a person. Maybe by training using senior operators, they know what they know, they don't know what the others don't know. So the training system may not have been appropriate. Or in this case, there's a context, there's a cultural situation perhaps, and supervisors are pushing to get production updates, work environment. So only you, if you were doing this investigation, would come away with an impression of what really mattered and where the kappas are going to give you the biggest bang for your buck, and therefore which categories are most applicable for that situation. If you choose good categories and you drill down further, then with the ones that are shown here, you give yourself an opportunity to deal with this particular situation if it were to reoccur. So to summarize on this topic of categories, I would like to just put forward that it has to be actionable, it has to be meaningful, and if it reoccurs, you need to be in a position to take action. So that means that it's associated with root cause. So your root cause categories, those that were presented earlier, are more meaningful than the higher level categories. Whereby if that category is identified, or if that category has been identified and it's improved, you're going to reduce the probability of error reoccurrence. So where do we see companies with on the scheme of things, in the grand scheme of things, in terms of their maturity around human error? And what we find is that there's some that are pretty much at a high risk level, and they're not investing. And we have other companies that are investing quite a lot, and the risks are quite a bit less. However, the costs to getting there are quite steep. And what we would encourage firms to do is to look at a moderate cost and to get to that low risk level. By listening in this kind of a webinar, hopefully you're coming away with a few tips on things that you can do. I would argue that you don't need to change things dramatically to see incremental improvements. Most sophisticated companies have robust investigation systems in place. And if you tack on to that a strong appreciation for this topic of human error, and you do your fishbone analysis, you do your root cause analysis in however manner you have people trained to do that, and you tack on their appreciation for why it is that both people make mistakes and why it is that the environment is sometimes prone to helping people make mistakes. If you give them that appreciation, they're going to be in a much better position to deal with the identifying contributing factors and dealing with those. Or even better, if they're supervising an area, a packaging line, or a tableting operation, or a purification skid, they can quickly they'll be in a position to proactively identify opportunities for error reduction just because they understand where those opportunities are. That's where you come into this moderate cost and getting to low risk. It doesn't have to, you don't need tons of new tools and software to get this right. I think strong understanding can do wonders. When we work with firms in this area, and this goes back to materials that Martin Lush had developed, it's around, we put a lot of attention on best practices. And these are shown here and quantified at a particular company, where we compared two sites and the behaviors or the perception of the best practices at these two sites for each of the 10 items that are listed on the axis of this diagram. And what we've done in this webinar is we focused a bit on the understanding of human behavior and quite a bit on the reporting aspect. All these things matter. Every one of these best practices matter. So we've just really touched on a very small sliver, but very important sliver, having to do with reporting and dealing with categories. So mature companies look to achieve, sophisticated companies, all companies look to achieve sustainable results. And how do we do that? Well, we measure where we stand today and set concrete objectives. We educate our people. We provide a methodology. And we certify personnel for key activities. And finally, we categorize, we measure, we track results. If we do these things where we know where we are today, we have a baseline, we educate, provide some tools, and certify people so that we know they're doing things, they understand this content, and they are doing things in a way so that they can embed that understanding in their actions, we're going to see improvement. And then if we categorize in a meaningful way and we track, we're certainly going to see improvement over time. So back to where we started. We put a lot of emphasis on both sides in our materials. We look at both sides, the reactive side and the proactive side. And if we can get folks to really understand this in a thorough way, both sides are going to be much more effective. And this is the format that we put forward. We have courses on the foundation, which is the reactive side, and the proactive side. And then we have shorter courses for people that would like to get an overview, typically managers, senior folks in an organization that are not touching deviations on a daily basis. We have a 1 day and a half day. But importantly, what we're looking to do is to put forward enough context so that people can take their existing systems and use them in a much more directed way to dealing with this topic of human reliability. Just a little advertising for NSF Health Sciences. There's some upcoming opportunities around human error in the UK and Europe. Dates are shown, and if you have particular interest in bringing some of our materials in-house, please contact us. Emails are shown. Austin Caudle's in North Carolina. I'm on the East Coast. And lastly, we have a LinkedIn group on human error prevention that Martin Lush presides over, and he'd love to get folks into that have an interest in this topic to contribute to the LinkedIn group and make it a worthwhile linkage. With that, I'm going to stop talking and take any questions that somebody might have. Thank you for listening to me, and I hope that the information I have put forward and some aspect of it has been useful to you in some way. We're just a few minutes short of the hour. If anybody has any questions, I'd be happy to try to take those.